All right. Well, good morning. Here's your warm-up for this morning. What you can make of all those fractions. And while you get going there, I'll just, of course, mention, hopefully it's obvious we're doing two different chapters together this time. Chapters 2 and 3 are combined. Chapter 2, we really worked on all our techniques for solving equations. Chapter 3, no way around it. They're really all different applications. You could call them word problems. Next section is really percent problems, which are a specific kind of application we use to write some equations. But we'll do what we can today to make some sense of some word problems. Basically, that translation step, I understand, is a challenge for everybody. If I didn't have so much more experience, well, I remember they were hard when I started too. But got this fraction problem. I put it up here for you to give it a try here, see what you come up with. I'm going to work it out a couple different ways in which you kind of consider your options. But I'll wait for you. You try to come up with an answer yourself. Looks like everybody's muted to start. That's fine. Just hope you can all hear me. Yes, okay, good, thank you. As we get into more and more complicated equations like this, there often is more than one way to go about doing it. But they should all end up at the same final place, final answer. The technique I presented last week involved getting rid of the fractions by finding the common denominator for all the fractions and multiplying the numerator of every fraction by that number. And that would allow the fractions to cancel out, making everything bigger, basically. So if you're approaching it that way, that would be the first step. Find that common denominator. Look at all those different numbers. Well, 3 is a prime number. You're going to need a 3. 5 is a prime number. You're going to need a 5. Well, the 2 would fit into the 4. So if you use a 4, that'll also take care of the 2 you would need. So the factors I would use to make a common denominator for all of those fractions would be 4 times 5 times 3, or a 60. So hopefully you're doing something like that, or something you know that works for you. This is the idea. Trying to understand what that's doing I'm making all the numbers 60 times bigger. If that's the case, 60 times this thing and 60 times that thing should mean that it's still balanced. It's still true that those two sides are equal to each other. I'm just going to make all the numbers bigger for some special reason. Right? I'm choosing this number because it's a multiple of these denominators. And if I multiply the top of a fraction, the bottom, the denominator ought to be able to simplify or cancel out. Here I'm just distributing. Got myself in trouble last week because I didn't show enough steps or something like that. There's just what it looks like. I'm distributing this 60 times each fraction. Now you can cancel right now if you've written it this way. Or you can multiply and get 180 divided by 4, 120 divided by 5. It should create an integer value. If I'm comfortable with canceling now, I could divide both of these by 4s. And it's a 15. Why? I'm thinking 4s and I write 14. Come on, hand. Get with the program. All right. That makes this fraction, right? 3 times 15 is now just turned into 45x for that first term. Plus, if I divide both of these by this 5, that divides into, there's a 12 there. So this is now plus 2 times 12, 24. All right. On to the other side. If I divide both of those by a 3, 60 divided by 3, I have 20. So I have 2 times 20 is now 40 x's. Right? And dividing by 2, minus 30. So that process was trying to get rid of all those x's. Excuse me, all those fractions. Thinking about the x's, that's my next step. You can move your constants if you like doing that first, or I can move my x's to get all the x's together, get all the constants together. I'm going to subtract these 40 x's from both sides. That leaves 5x plus 24 equals still the negative 30 over there. Well, I need to get all the x's alone. Let somebody in here. So I'm going to subtract the 24. 5x's equals negative 54. Finally, to figure out the 1x value, dividing by 5. And just writing it over here, x equals a negative 54 over 5. Messy fraction. That's what happened. Questions about that technique? Thanks, Kenny. All right. So that was the way I presented it last week. As what has often been found is that students like doing that because it gets rid of the fractions. I'm going to do it one more way. And if you really like doing it this way and you can make it work for you, it's totally fine. I'm just going to work with the fractions. Was there a question?
Question?
Yep.
What is the best way of going about just like a reminder on how to find the lowest common denominator?
Okay. Well, in this case, I had 1, 2, 3, 4 different values, right? What I was first kind of trying to recognize or point out is, well, these are, okay, let me back it up. A common denominator has to be a multiple, some times each value, right? It's got to be a multiple of 4. It's got to be a number 4 divides into. got to be a number 5 divides into. All those numbers have to divide into whatever bigger number you come up with. So that bigger number has to be built out of factors of all these different numbers. Well, 3, there is no other factor but 3, so it has to have a 3 in it. 5 has no other factors than 5 and 1. It has to have a 5 in it. I know I'm going to go through a long answer here. Now, 4 is 2 times 2. So it also includes this 2. So it has this 2 inside of it. I could say I need a 4, or I might write it as 2 times 2 if I was really showing all the prime factors. So what I come up with has to have the factors of 3, the factors of 5, the factors of 2, and the factors of 4. So I need, since these are unique, I needed all those different pieces. If these weren't prime numbers, like if I had a 15, I might break it down and notice that 15 is built out of 3 and 5. So I would need a number that has a 3 and a 5 as a factor in it in order to be divisible by 15. Or if it was, let's see, just making up something here. If it was a 12, right? I need my common denominator to be a multiple of 12 or have all the different factors of 12 in it. So it needs a 3 and a 4, or a 2. It needs 2 factors, prime factors of 2 and a 3 in it to be divisible by 12. So
Makes sense. Thank you for that refresher.
Breaking it down into all the prime factors. The other possibility, which is kind of like, you might say a chart method, is to just start, first of all, maybe just hope that you recognize the 4, the 2 fits into the 4. We could like save a step, but like, well, 1 times 4, 2 times 4, 3 times 4, 4 times 4, I could just keep going and get a long list of all these factors of 4. Now, just knowing where we ended up here, that'd be a long list. But then I could do the same thing for 5s. Now, this problem has 4 different numbers. Usually we just were looking at 2 and we were adding. But here I could keep going, right? Eventually I'm looking for, well, okay, 20 works for 4 and 5, but 20 is not going to work for 3. I'd have to do this long list for all the 3s. And actually it would be kind of a long list before I actually got to 60 that worked for, say, all 3 of those numbers. But you can just find all the multiples until you find a common multiple. If I was just worried about 4 and 5, I'd stop at the 20. So you can just work down a list like this. Breaking it down into all the different prime factors is the other way to do that. Okay. Erase. Here I go.
Professor, can I ask you a quick question?
Okay.
If I recall, I'm just trying to make this easier for me to remember. The only time that I need to find the lowest common denominator is when I'm adding and subtracting. Is that correct?
That's right. If you're multiplying and dividing, you don't need that. You know, you're just making it harder on yourself, really. Yes, adding and subtracting, they need to be the same size pieces to be able to combine them. Right?
So I understand how to find the lowest common denominator. I just wanted to verify that. Thank you.
Yep, good. Okay, so I just want to, I don't know that I even walked through one all the way this way, but what if I just want to practice fractions? I'm okay with working with fractions. Well, I'm not going to try to get rid of them. I'm just going to do what I have to do to combine or add or subtract those fractions where necessary. Now, if I'm going to approach it that way, I probably would rearrange first. Let's get all the variable terms together and all the constant terms together. Like I might say, okay, I'm going to get all the variable pieces on the left and the constants on the right. This should look like I'm just solving an equation, and at the very end, I'm going to deal with fractions because it's got fractions. I'm not trying to do any special trick technique like getting rid of the fractions. So if I'm subtracting that, right, I get 3/4 x minus 2/3 x. Now this is still here. All right, so there's my two pieces with x in it. I still have this constant. I want to move that to the other side, so I'm going to subtract that one also. Shape the board here. I'm not worrying about the fractions yet. I'm just moving things to their own side, you might say. Right? That's supposed to look like a 3. Here I got all the x's on the left and all the constants on the right. Now I'm going to worry about combining them. I want to put those two. How many x's do I have? Well, I need a common denominator for these two numbers. In this situation, it's only these two I have to worry about putting together, not all 4, right? What's the common denominator for 3 and 4? How about a 12? If I multiply both of these, now I'm getting a common denominator, right? I'm doing the same to the top and bottom of each fraction. This is getting a common denominator for these fractions, not getting rid of the fractions. If I want to make this 12, some 12ths, I had to multiply by 3 over 3 and get to 9. Here I'd have to multiply by 4 over 4 and get to 8. That would allow me to combine all those x values. My next step, I would subtract and say, oh, I have 1/12 of x left. But I have to do the similar thing on the right side. I just have these two fractions to combine. Minus and more minus, it will be some negative number. What's a good common denominator for 2 and 5? How about 10? Right? Times 5 gets me 5/10. Times 2 gets me 4/10. Combining -5 minus 4 more is -9/10. This fraction of x equals this fraction. I'm going to go over here, okay? Sure. So how do I undo, you might say, dividing by 12? I'm going to multiply both sides by 12. This says, I'm okay with fractions. I know what to do with fractions. I just get the common denominator. I can handle it. That's supposed to look like multiply, right? So here this goes away and I have x equals whatever mess I'm going to get over here now. Hopefully it's the same number I came up with the first time. But let's see. Before I multiply, can I cancel anything between this and this? Notice I use the parenthesis because of the negative sign. How about I divide them by 2? All right, I think that's all I can cancel. Still my negative 54 over 5. I do think that was the same number I had the first time. So now you can put that away and forget it, or if you like doing it that way because it's just moving things around like all the other equations and you just work with fractions at the end, you can do it that way. Notice what was really different is that I built a common denominator. Same thing top and bottom, same thing top and bottom. I wasn't just getting rid of the fractions by multiplying the numerator. So if you would like to, maybe send me a message later if this made more sense to you and say, oh, thank you for doing that. I really liked it that way. I'd rather do it this way than say the first one. I'd just be interested in hearing that, something like that. But just wanted to use that as an example and a warm-up this morning.
I like that way better than the other way. It makes more sense to me, at least.
Yeah, see, that's what I get. Following the textbook and the way the technique they presented, you know, I almost think of that other method as like a trick.
I agree with you, Devin. That way is much, no wonder I'm confused. I'm going to stick with that.
Okay,
Thank you so
Yeah,
much.
in fact,
I would like to go back over this with my Math Marvels coach afterwards. Where in Mom do I find the recordings for these lessons?
Oh, it's about a bar or two down below the calendar, right near the top. It says Zoom class recordings.
Okay, perfect. Thank you.
All right, what else was I going to do? Oh, here we go. Whoops, let's do it for, how about one of those? Wait a minute, there's parentheses. And let's see. Just thinking about this formula. I made up a formula and I left something out. Give me a second here. I got to throw something else in there. Excuse me. Sorry. Got to put another letter in there. This is actually the area of a trapezoid formula, where these are often called the bases, like A and B, the two parallel sides. But then, of course, there's that height dimension. We won't worry about how that happens, where that formula comes from right now. But what if I wanted to solve this one for that little a? How do I go about doing that? Now, you might think, not unusual, oh, well, I've got parentheses I need to distribute. That would I'm just trying to get this plain little a all alone, but it's trapped inside of parentheses right now. If I actually distribute, I'm kind of making each term inside a more complicated. A cleaner method is just, what if I just got rid of these pieces on the outside first, then I would just have a plus b. So how do I, that's what I'm suggesting, it'd be more efficient or cleaner. How do I get rid of multiplying by a half? That's the opposite of, that's like dividing by 2, right? Multiplying by 1/2. How do I undo that? Multiply both sides by 2. And I'm doing lots of little steps. You could do a couple things at once if you really understand what you're doing, right? That makes these two cancel out. Now, if I'm really still just trying to get rid of those things that were outside the parentheses, how do I get rid of multiplying by h? How do I undo multiplying by h?
Divide by h.
Divide both sides by the h. And I'm just going to continue here like that. And they go away. Now I don't have anything multiplying this quantity, so I don't need the parentheses anymore. I just want the a all alone, and it has a b added to it. I need to undo adding a b. That's the opposite. Let's subtract the b from both sides. Now, if I do that, this is a fraction, a term all by itself. I'm going to subtract the b from that whole thing. It's got to be out here, a separate piece. Don't try to put that b inside of that fraction. That's what I was getting at. So there it is. The a is equal to this combination of things. And then there was this subtracted b from all of that. So the sort of the gist of that to start with is, if what you're after is inside of parentheses and there's extra stuff on the outside of the parentheses, I would encourage you to think about undoing those operations first. You know, got rid of the half, got rid of the h. Then what's left might not be quite so complicated. Okay. That might have actually been a homework problem. Hint, hint, right? Maybe. Okay. Well, 3.1, my point was, yes, chapters 2 and 3, we put them together because chapter 3 is just applying all the equation solving stuff we learn in chapter 2. So we have this week and a little bit, next Monday's a President's Day holiday. Next Thursday is our test then over those 2 sections. All right, 3.1, right? Get my notes ready here. Identify what you are looking for. That's usually kind of the first step. Read the problem carefully. Often it's like sometimes in the very last sentence. Story, 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 last sentence. Find the number of blah, blah, blah. That's what you're looking for. Right? And define a variable or choose a variable, a letter to stand for what you are looking for. You know, something like that. Let X equal the thing I'm looking for, right? Write an equation. Write an equation that describes this particular situation. Sometimes translating the big story into, say, can I write it? Can I condense it into a simple sentence? You know, 350 is the result of what I'm doing. And this, make sure I'm not kind of skipping anything here. But basically from there, once you get there, you're going to solve. And especially for application or word problems, you know, write your solution as a complete sentence. And you might say, please practice that final step, say on the hand-in homework, where you actually have to do it on paper. I think this week's hand-in homework probably has some of these kinds of problems. Okay, well, we have all those different kinds of phrases that we've tried to translate earlier in our term, and we're going to put them together and say this expression or situation is equal to something, and so we're going to be able to make an equation out of it. Now I'm going to try something here. I'm going to, rather than me shortcut, try to quickly write a paragraph story here, I'm going to share my screen here, and I'm going to use some of the textbook problems here. I'm going to sort of talk it through, and you'll have to look. Where's my share thing? There it goes. See if this will work. All right. And come on, Steve, click. Oh, I clicked on the wrong thing. Let's try it again. I didn't click over there. Here we go. Click on that. There we go. Highlighted the correct thing. All right. So these are actually problems out of the textbook for section for 3.1. And we're going to try to, I'll have to try to talk through this process with you without you seeing what I'm doing. And hopefully it makes enough sense that you will write down your thoughts, and then we'll go back to the screen and I'll do some, you know, do my part of it. So number 3, just looking at this problem. This is some version of what I might just call a number problem here. 2/3 of the children in the 4th grade class are girls. If there are 20 girls, what is the total number of children in the class? So as I suggested, almost like working backwards, what are we looking for? The total number of children in the class, you know, boys and girls and whatever. What is the total number of children? So there's your first step. Identify what you're looking for. Well, define a variable, total number. Maybe you want to choose T, or maybe you just keep using X, whatever. I'm going to write down on my board, my paper, let X be the total number of children. You can't see me because I'm sharing, but I'll just say that again. I wrote, let X be the total number of children. If we were doing this on paper, a paper problem, we actually like to see you define your variable. Tell us what you're saying that letter stands for. And it kind of like justifies what you're going to do with it after that, you know, your argument. All right, next step. Well, can I write an equation? Maybe I want to simplify this whole story to one sentence. If I was going to do that, I would say something like, well, I know 2/3 of the class are girls, right? So 20 is, right here, I'm going to write this on my board. 20 is 2/3 of the total. Write that down. 20 is 2/3 of the total. Now that's kind of condensing, rearranging the story here, but that I can translate just about directly into an equation. Remember the is or sometimes was is where the equal sign goes. So I'm going to say 20 equals 2/3 times x, 2/3 times the total. And there's a not too complicated looking equation. And now I want to find out what x is. It's being multiplied by 2/3. So I'm going to cancel out that 2/3 by, how do I cancel out a fraction of both parts, right? Multiply by its reciprocal. So I'm going to multiply both sides by the reciprocal of 2/3, which is 3/2. In a second, I'll show you my board. Hopefully it looks like what's on your paper. Simplify and say, I come up with my x equals 30. And finally I say, there are 30 total, abbreviating a bit. Now I'm going to stop my share and look at my board for a second, see if that looks like what you did. Not too messy, I hope. But anyway, here, just talking through what I do. Identify what you are looking for. Well, we were looking for the total number of children. Define a variable. Let x be the total number of children. That's what I was looking for. So that was kind of my first step. Figure out what I'm looking for, and so I need something to stand for that. I tried to write an equation, but kind of intermediate step, I tried to simplify the story. 20 girls is 2/3 of the total, right? 20 is 2/3 of the total. Kind of help me to organize it, simplify it, because that pretty directly translates to my equation. 20 is 2/3 of the total. And now I solved it. To undo multiplying by 2/3, I multiplied by 3/4. 3/2, I was thinking ahead already. 3/2, the reciprocal on both sides, right? Cancel some 2's out of here. So I had 3 times 10 was my x, so 30. X is 30, good, I'm done. 30 what? There are 30 total students. I still cheated a bit, but I wrote my answer in a sentence that was in the context of the problem. Okay. Let's try this again. Hope that worked okay. This approach here, sharing, and then, uh-oh. No, I must have, that's not sharing. I think I touched the wrong thing. Where's my Zoom? Go back. All right, let's try that again. Here we go. And sharing. I'm gonna share this again. And I'm gonna move to, excuse me. How about I'm gonna just scoot up. Let's see if I can do that this way. Yeah. Can you, number 6 here, M&M candies. You never eat those anymore, oh well. Can you sort of follow this process and try this on your own? This should be very similar in structure, you might say, or how you put it together to that first one that I did. Time's flying. I can tell we'll probably pick up tomorrow and do more of this and then continue on. Luckily, I scheduled 3 days basically for the first 2 sections here, expecting needing some overlapping time. How many candies? Again, kind of looking for a total, right? How many candies are what you're looking for? Choose a variable. Maybe you like C for candy or something like that. All right. We want to write an equation. Can you maybe write that intermediate, that sentence that kind of says this is equal to that or something? Can you simplify it, rearrange it in your own head? One-fourth are red. 23 is 1/4 of the total. Can you write an equation based on that sentence? Solve it. How many candies did you get?
92.
I got 92 also. All right, I'm going to stop my share and you can just look at my work on the board, see if it's similar to what you did, okay? Here we go. How many candies total I'm looking for? I said, let's let C equal that total. I used C. 23 reds is 1/4 the total. So 23 is 1/4 the total. Multiply both sides by 4 to get rid of that fraction. I got X is 92. There are 92 candies total. Right. Gonna keep going like this. All right, try it again. And just looking over here, let's try number 10. Yeah, little different. Similar process, same process, but the relationship is, you might say, more complicated here. See if we can sort it out. Jeff is lining up children's and adults' bikes. The number of children's bikes is 9 less than 3 times the number of adult bikes. There are 42 adult bicycles. How many children's bikes? Oh, too many pieces here, right? So please think of this with me. To begin with, well, it says there are 42 bikes. So how many children's bikes? Not quite too complicated. How many children's bikes? That's what we're looking for, right? How many children? How many child bikes? All right, pick a variable for that unknown quantity. I'm gonna use C myself. Let C be the number of child bikes. All right, now the number of child bikes is 9 less than 3 times the number of adult bicycles. 9 less than 3 times the number of adults. Here you can almost like, we actually do this at the end of the chapter also, at the end of the term actually, with some of these similar kind of problems. It's kind of like we have two different things, child and adult. So you could think of this as 9 less than 3A for adult, right? 3A minus 9, but they told us what A was. They told us the number of adults. 9 less than 3 times the number of adults. Really, C is, right? The number of child, C is 9 less than 3 times 42. The number of child bikes is 9 less than 3 times 42. We happen to know how many adult bikes there are. C equals, well, all right, 9 less than. This is a subtraction problem, but the 9 is subtracted from the other quantity. So it actually has to be the other thing minus 9, right? 3 times 42 minus 9. Really not a whole lot of solving to do, you might say, just kind of have to do that calculation. 3 times 42 minus 9. Unless I'm missing something. 126 minus 9, 117. 117 child bikes. And I'll let you look at what I wrote here. See if that makes some sense. Losing my voice today. All right, so that was a little more complicated paragraph, right? A couple things I have to sort through, but how many child bikes is what we were looking for. And I said I'm going to let C be the number of child bikes, C for child. I just chose a letter that fits in the story. So the number of childs, C, is 9 less than 3 times the number of adults was 42. Squeeze it in there, sorry. C equals, so 3 times 42 minus 9. 9 less than 3 times 42. This was the kind of expression actually I saw in the last test that folks kind of did backwards. They did things like 9 less than. Maybe when you saw a subtraction, that's always first number minus the second. Well, that's when you say the difference of 15 and 2 is 15 minus 2. But 9 less than something else, this has to go first. Hope that makes some sense. I got this. So 117 child bikes, not a really nice complete sentence. But okay. Now there's my mold or model. Let's see if we can come up with. Let's just do the one next to it. I'm going to ask, okay, if this is going okay, I'm going to pull up another one here and have you try to set it up yourself. Let's go right next to it. This is number 11 in section 3.1 in our textbook. Okay, and see if you can set this up, work through the process yourself. Right, I can see Kayleen is thrilled to death. I hope you're getting it. Yeah, no, I'm really hoping that's a good thing. All right, I get this. I understand. Maybe that's what that look means. Philip pays $16.20 in rent every month.
I understand them, I just don't like them.
Yeah, that's fair. That's honest. You know, if you look at the textbook, they spend the whole first page or two about try not to be negative about word problems, you know, think positively. Yeah, anyway, pumping you up. And this is 120 more than twice what Paul pays. How much does Paul pay? All right. How much does Paul pay? And both are P's. That's unfortunate, Philip and Paul. Okay, so I'm going to just say let X myself. All right. You keep going. I'll stop talking for a second here. See if you can write out this next thing. Okay. Paul's got a much cheaper apartment, right? Who's got a number? Who wants to take a chance here? What they get? Hmm.
9:30.
9:30. I'll double check my work, but not what I got. Anybody else confirm 9:30?
I might be off. It's very possible.
7:50, I think.
Who was that? What was that?
7:50.
I have to say that's what I got. So I'm going to stop my share here and look at my work. See if it agrees with your thoughts. Huh? So we're looking for how much does Paul pay? So I'm going to let X be the amount that Paul pays. I really had to slow it down and go back and say, Paul, Philip, both P's wanted to write this sentence. So $1620, right, is 120 more than twice what Paul pays. So that sentence, if you can condense it into a sentence like kind of puts it all together with an is or something in the middle, that might be what you can then translate to an equation. So a couple expressions, right? Twice what Paul pays. How do you write that? Twice what Paul pays. 2x. 120 more than twice what Paul pays. Now, because it's an addition, you could have done it in opposite order. It doesn't matter, but I had 2x plus 120. Or 1620 is twice what Paul pays plus 120. That's what I got out of this. Solved it here. I subtracted the 120 and got 1500 is 2x. So divide by 2, x was 750. Definitely need to put it in context. You know, what are the units? What is this talking about? Paul pays $750. And kind of abbreviated short sentence there, but you do want to restate your solution in terms of the context of the problem, like that. All right, we really kind of just worked through the first of, I would say at least 3 different types of word problem situations in this section. So we will definitely come back and pick it up again tomorrow. This might get you through the first couple, 3 or 4 problems in section 3.1 homework if you want to just get started and give it a try. But we do need to come back and talk about some of those other forms or shapes you might see tomorrow. All right, we're out of time. So I gotta go and I gotta let you go. So yeah, I might, just a final word about the fraction problem. I'm sure it was kind of obvious. I was a little frustrated last week about it not clicking. And I actually shared it with sort of the Math Marvels teachers that this was an area that caused some frustration. So I would be interested to hear back or encourage you to share, those of you involved in that program, and see if that worked any better for you, and see what kind of feedback you get from your the helpers there. But anyway, let you go for now. Gotta go, and I'll see you again tomorrow. We'll pick it up and do more. Okay?
Thank you. Have a great day.
You
Thank
too.
you.
All right.
Have a great day.
Take care, everyone. Have a good one.
You guys too. Take care. Bye-bye.